As you can see, we are getting some Siprotec block, so we'll have to provide the line side voltage for it. So let's provide the line side. We have simulated the VT connections for this. So I will just turn this breaker on. This provides the line voltage to the incomer. So you will see that it's all okay now. Everything is good. We are good to go. There is no alarm, no error. All LEDs are green. So now we can close the breaker. Okay, so we'll try it. So we have 132 kV circuit breaker is already closed, and we are allowed to close the 11 kV breaker. I close it. So the breaker is closed. So this is again, I will reiterate that this is the 11 kV Siprotec relay that we are testing right now. We are receiving the 11 kV CV close permissive from 132 kV side, and we were allowed to close the breaker, and we have closed it. So I will open it. Now we will retry this test by inverting the signal on the 132 kV side. So wait. So as you can see, we configured binary input 1 of 132 kV Siprotec relay as a permissive signal. So we will just remove this signal, then it will become 0. So for that we have interlocked with the test plug for only testing. So as you can see, so the binary input 1 is 0 now. There is no signal here. Now we will go to the other side, 11 kV Siprotec relay. As you can see here, now this LED is red, 132 kV CV closed open. So it means now 132 kV CV is open, and I am not allowed to close the 11 kV breaker. Actually 132 kV circuit breaker should close first, only then 11 kV can close. So we'll also show you the signals. Here show the binary output of the 11 kV Siprotec relay that is going to the ABB. So it is BO3. As you can see, the Siprotec relay output BO3 is 0. This is the output of this Siprotec relay to the ABB relay. So please show in the ABB relay which was that signal? X20. So as you can see, X20 input 1, it's false. Okay, so we have checked this, and now we will actually try it. As you can see, we are not there is no permission from 11 kV side. From 132 kV side, and we will try to close the breaker. All other conditions are okay. As you can check, the voltage is present. Everything is okay, so we will try the closing of the breaker. See, it is not closing. I am giving the command through this TNC switch, close, but it's still open, not closed. So this completes our first signal check. We have checked the 11 kV CV close permission. The 11 kV CV can close only when 132 kV circuit breaker closes. Only after that we can close it. So we have checked this. Both the conditions, the permission also checked and the invert signal also checked. So now we proceed to the next signal. It is the same. It is also coming from 132 kV side to 11 kV side. This signal is the intertrip signal. I will show you. Any fault at 132 kV breaker, fault intertrip from 132 kV. So this is an intertrip from 132 kV to 11 kV. So, and this signal is coming to the 11 kV Siprotec relay through a fiber optic link, and this 11 kV Siprotec relay provides the signal on output BO number 2, and it goes to the ABB relay input number X115BI6. So now we will check this signal. Okay, first give me the permission to close 11 kV breaker so that I can actually close it, and then we will check the actual trip of it. So now I have the permission. I have the permission to close the breaker. As you can see, the 132 kV breaker is closed, so I will close it. So now the breaker is closed. Now I will simulate the intertrip from the 132 kV side. So for that we have configured another input in the 130. This is 132 kV Siprotec. We have configured another input which is binary input number 2. So when we force this input high, then we will get an intertrip signal on the other side, and you will see that the breaker will trip. So right now the breaker is closed. Just now I closed the breaker of the other side, which is 11 kV. So as soon as we force this input, you will hear the sound that the breaker will trip. See, now I will show you the breaker has tripped, and we'll also have the indication here. You can see the breaker has tripped. We have the trip LED. The breaker is open now. And we also have assigned an LED for this, which is LED number 4 intertrip on the Siprotec relay. It means this 11 kV Siprotec relay has received an intertrip from 132 kV Siprotec. So now we'll show you the exact signal. So this is coming on binary output number 2, okay, and this relay, from this Siprotec relay output number 2, it is coming to X115 binary input number 6. So 6 is 2 now. So, and on the ABB relay it's also configured that we have received 132 kV intertrip. Okay. So anything else in this? So that completes this intertrip signal from 132 kV to 11 kV. We have shown you the actual tripping of the breaker, and also we have shown you the signal input outputs, the signal conditions on the relevant input output card. So now we move to the next signal, which is marked here as signal number 3. No, okay. So first we will check all those signals which are coming from 132 kV side to 11 kV side. Let's first check all those signals. Those are total 3 in number. 2 we have already checked, which are coming from 132 kV to 11 kV. The first signal that we checked was permission from 132 kV to close the 11 kV breaker. Next signal was intertrip from the 132 kV side. Now third signal we will check. It's also coming from 132 kV side. Okay. So what is this signal? This signal is the status that 132 kV CV is open, so that the 11 kV earth switch can close. We have the permission to close 11 kV earth switch. So this signal is coming from 132 kV relay through this FO link to the binary output. It's coming to this 11 kV Siprotec relay through a fiber optic link, and it is coming on binary output 5, and through binary output 5 of Siprotec relay it is going to ABB relay X120 binary input 4. So this is the hardwired link between Siprotec 11 kV Siprotec relay and ABB relay. So we'll show you this. Initially we will normalize this. We will simulate the condition in which we can close the 11 kV earth switch. So this is a signal from 132 kV side to close the 11 kV incomer earth switch. So we'll check the condition. So there are other interlocks as well in this. For the 11 kV incomer, if we want to close or operate the earth switch, the breaker needs to be racked in. As you can see now, right now, this is red now. Okay, that signal is also red. That means the breaker is racked in now. As you can see inside also, the breaker is inside now. It's in service position. So in order to operate the earth switch, which is down there, you can see we need to operate this lever. We need to press this. So this should completely go down. Then we can insert the crank lever and operate the earth switch. So, but this we cannot operate this now because it's interlocked with the circuit breaker. So first of all, we need to normalize this. Before we check the interface signal between 132 kV and 11 kV, we will normalize. We will see that we can operate the earth switch. So for that, I will rack out the breaker first. Okay, you hold this. But first of all, I need to open the breaker. The breaker is closed, so I will open the breaker. I opened the breaker, now I will rack it up. racked out the breaker. As you can see, it's green now. This signal is green now. The breaker is open and it's racked out. And as you can see in the window also in this glass, the breaker is out now. It's racked out. So now we will check if we can operate the earth switch. Still unable to. This is the hole to insert the rack, so I cannot fully